Rahim. Assalamu alaikum. I am Dr. Ahmad Nauman, and today in this lecture we will discuss about chemical properties of advanced materials. And among chemical properties in this lecture specifically we will discuss about the corrosion resistant properties of advanced materials. So this topic is a bit lengthy, so it's not possible to finish this in one lecture. So we will have two lectures on this topic, and this is the part 1. And today in this lecture we will first briefly see what are the chemical properties, and among chemical properties then we will discuss about the corrosion, what is corrosion, how it happens, and what are the disadvantages of corrosion, and how can we prevent materials from being corroded. And then we will discuss about the use of advanced materials for the prevention or inhibition of corrosion. So let's discuss with this our first lecture. So before we start our today's lecture, you know that it is about the chemical or corrosion resistant properties of the advanced material. So when we studied about the magnetic properties of advanced material, so there we have already discussed in detail that what are the advanced material, or what do we mean by this term of advanced material. So I think we don't have to discuss that what are the advanced materials again. So in today's lecture we are going to discuss about the chemical properties of advanced materials. So what are the chemical properties? How do we define the chemical properties? So how a material interacts with another material is known as a chemical behavior of that particular substance. So we can say that it is a response of a material or of a substance to another material, or we can say it is a lack of response. What do we mean is that when we talk about the reactivity of a material, so we can say that either it is reactive or non-reactive. So how it reacts, it is kind of response, that if we have a substance and it reacts with another substance, and how both of them react together is a reactivity or the response of one material to another. And lack of response means there are some materials which are inert and they don't respond to other materials, or they don't interact with other materials. So all of these things come under the category of chemical behavior or chemical properties of materials. So let's briefly overview some of the chemical properties, and then we can go further and discuss with our lecture of corrosion resistant properties. So there can be different kind of reactions. For example, when we talk about reaction, we have the flammability. So what is flammability? We know that flammability is an ability of a substance to get burned, or it's resistant to burning. So flammability means how quickly a substance is burned. So it is a very important property, and specifically when we have to store different materials, for example the solvents, and then we have to take care that the substances which can easily catch flame, so we have to separate those to avoid fires. And the flammability is a chemical reaction. Then we have different other chemical reactions. For example, how a substance react with water. For example, we have sodium. So whenever we put sodium metal in water, it catches fire. So another thing is how a specific substance react with an acid, whether it get dissolves in acid, or it makes some other substances, or it doesn't react with acid. So These are all type of chemical properties. Similarly, we have toxicity is a kind of chemical property that it is the measurement of ability of a substance, that how it damages some animals, like some other animals or plants. So how toxic a substance is to a specific species. So that is basically dependent on its chemical properties or its reactivity with those living beings. And then, for example, we have heat of combustion, that how much heat is released when a substance is burned, or chemical stability, how stable is a specific substance. And then for example, we have oxidation, that how a metal or a substance is oxidized, like it and when we talk get an example of oxidation from our daily life. So we know that then if we cut an apple and put it outside, so after some time it's get brownish in color. So that is actually due to the oxidation process. This is the same oxidation process which actually causes the corrosion or the rust in the steel or iron. So it is a type of chemical property or chemical reaction, the corrosion resistance. And in this lecture actually we will discuss about the corrosion, what is corrosion, and then corrosion resistant properties of advanced materials. So the word corrosion actually stands for metal or material deterioration or surface damage in an aggressive environment. Corrosion itself is an electrochemical oxidation process. We can call it is a redox process in which both oxidation and reduction occurs. In corrosion process normally होता है कि जो metal होता है हमारे पास ये normally transfers electrons to the environment, normally जो electrolyte है, water है और oxygen है, and it is oxidized as it gives electrons, and those electrons are actually accepted by the analyte, and mostly if it's oxygen in the environment, so it takes those electrons and is reduced, and it makes oxides mostly with the metal. So these metal oxide, for example in the case of iron जो है they form actually the rust on the surface, और हम कहते हैं कि जो metal जो है वो corrode हो गया, there is corrosion happening over the surface. So basically it is an oxidation reduction process in which metal surface is oxidized by reaction with the environment, mostly water and oxygen.
Imagine four objects: an aluminium toy, an iron nail, a copper pipe and a gold ring are left out in the open for many years. Which of the four materials do you think will be in the best condition when they are rediscovered? Pause, think and continue when ready. If you think the gold ring is likely to be in the best condition, you're right. The copper pipe and the iron nail will appear in a worse condition, but the aluminium toy is also preserved very well. Most likely the iron nail will appear in the worst condition. This is because of corrosion. Corrosion is described as formation of compounds on the surface of a metal when it is exposed to air and or water or an electrolyte like salt water. Typically, once a metal corrodes, it forms compounds known as oxides or hydrated oxides. The nail, made of iron, rusted. This, by the way, is the only time you should use the term rusting. All other metals are considered as having been corroded when they react with water and or oxygen in the air. But why would the nail be more corroded than the aluminium toy, the copper pipe or the gold ring? Have you any ideas? Pause the video and continue when ready. The reason is the metals all have different reactivities. Iron corrodes faster because it is more reactive than the copper and the gold. But you may be wondering, well, why didn't the aluminium toy corrode the fastest? The truth is, the aluminium is more reactive than the iron, so it reacts fastest with the oxygen from the air, forming aluminium oxide. Aluminium oxide is very unreactive because once the oxide layer is formed on the surface, it binds very tightly to the surface of the metal, so no cracks can form and cause further corrosion. Here's a challenge. How might you use this idea to protect the iron now? The answer is that by covering a metal like iron with another more reactive metal, like zinc, is that the zinc forms the zinc oxide layer quickly. The iron underneath is protected. This process is called galvanizing and can last up to 100 years. If you think of the metal on a bike, corrosion can be prevented by painting the frame, a static part, or greasing the metal parts like the chain which moves, or by covering it with a thin layer of a less reactive metal like tin, copper or gold, but that would be very expensive.
So in some cases ये भी होता है कि जो metal होते हैं they react with the oxygen which is present in the air and they form metal oxide on their surface. And we call this process as a natural passivity or natural resistance to corrosion, as those layers are resistant to the corrosion. So the formation of that thin layer actually blocks the environment to react with the underlying the metal surface, and because it cannot undergo further reaction, so there is no more corrosion or no more reaction with the environment. So an example which we also see in the animation is that oxidation of aluminium mostly results in the formation of aluminum oxide के जो के resistant होती है काफ़ी and that it doesn't react. So that thin layer of aluminum oxide is actually formed on the surface of the metal, and it actually protects it from further contact and reaction with the oxygen. So due to the formation of that layer of aluminum oxide on the surface, जो नीचे वाली surface होती है that doesn't react and mostly जो है ये corrode नहीं होती, it remains safe from the corrosion. But in some cases ऐसा भी होता है कि जो protection film है जो है कई दफ़ा ये damage हो जाती है due to certain अगर उसके ऊपर कुछ stress पड़ा है या कोई बहुत ही harsh जो है वो environment है. In that case that actually film जो है that can be damaged or destroyed, and we call it that it is repassivated. The material जो है कि वो repassivate हो गया. So if we want to prevent corrosion, we have to understand कि ये कैसे होती है, because एक दफ़ा अगर एक मेटल जो है वो corrode हो जाता है, एक दफ़ा rusting हो जाती है, then जो है उसको ठीक करना जो है वो मुश्किल है. Once it is corroded, so then we have to replace it. So the only way is to आप corrosion होने ही ना दे, you have to prevent it earlier. So there is one important thing to know, that corrosion always happens in the presence of oxygen and water. So it requires both oxygen and humidity to happen. So if we हम इसको कोशिश करें कि इसका अगर जो हमारे पास metal surface है, it is not exposed to oxygen and water, so in that way we can prevent the corrosion to happen. Another point is that it is the formation of rust or the corrosion is not the direct reaction of iron or a metal surface and its oxygen, but instead it is a electrochemical process. It is a redox process in which oxidation of metal occurs, and also there is a reduction of the oxygen which form the metal oxides on the surface, but they are not directly reacting actually the oxygen and the metal.
Experiment. Place an iron nail in 4 test tubes. Fill one with regular tap water until the nail is submerged. Fill another with regular tap water and add half a spoonful of sodium chloride regular table salt. Shake from side to side to ensure that sodium chloride fully dissolves. Fill the third test tube with recently boiled water and add a thin layer of oil. When we boil the water, we remove any dissolved oxygen, and the layer of oil prevents any oxygen from further dissolving. In the last test tube, add a spoonful of calcium chloride. Calcium chloride removes moisture or water. So in the first test tube, the nail is exposed to oxygen and moisture. In the second test tube, the nail is exposed to oxygen, moisture, and salt. So in the third test tube, the nail is only exposed to water. In the fourth test tube, the nail is exposed only to oxygen. Stopper all 4 test tubes with a rubber bung and let stand for a couple of days. You will find that the nails in the first and second test tubes have rusted. In particular, the nail in the second test tube has rusted more than the nail in the first test tube, and the rust has likely flaked off. You may see a reddish-brown precipitate at the bottom of these tubes. The nails in the third and fourth test tubes have not rusted. So what has happened here? The iron has undergone an oxidation reaction, forming hydrated iron trioxide or rust. Salt and acid act as a catalyst for this reaction, which is why the nail in the second test tube formed more rust than the nail in the first test tube.
So from the animation we have learned that it requires water and air for the corrosion to happen, and also we learned that अगर वहाँ पे salt present है, the presence of salt actually act as a catalyst and it enhances the corrosion process. So that actually explain कि जो ऐसे areas जो hilly areas होते हैं जहाँ पे mostly बर्फ़ पड़ती है और उसको बर्फ़ को पिघलाने के लिए रोड पे जो है mostly salt यूज़ किए जाते हैं different. So that वो जो areas होते हैं mostly वहाँ पे जो automobiles होती हैं वहाँ पे rusting ज़्यादा होती है, and that actually explain कि वहाँ पे रस्टिंग क्यों ज़्यादा होती है, बिकॉज दैट सॉल्ट एक्चुअली जो है वो डिज़ोल्व हो जाता है वाटर के अंदर, एंड विच एक्चुअली enhance the process of corrosion over there. And another thing which we learned in the animation was the redox process, which is occurring during the corrosion. So let's watch another animation which is describing in detail how that redox process is occurring, the oxidation of metal and the reduction of the oxygen is happening. So let's watch another animation.
The rusting of iron is an oxidation reduction reaction. Here we can see the iron being exposed to a water droplet containing dissolved oxygen. This exposure causes each iron atom underneath the water droplet to give up 2 electrons to become iron 2 ions. This process is known as oxidation. Next, electrons are released and flow throughout the droplet, where the oxygen dissolved in water receives electrons to form a hydroxide ion. This is the reduction process. Next, iron 2 ions combine with hydroxide ions to form iron 2 hydroxide. Finally, iron 2 hydroxide reacts with water and oxygen to form iron 3 hydroxide, which is also known as rust.
So how we can protect the metal surface and prevent the corrosion? So it can be carried out in many ways, and there are different methods to prevent or control the corrosion process. So main requirement for preventing corrosion is that we protect the surface of a metal or iron or whatever the metal is, so that it cannot interact with the oxygen and the moisture from the atmosphere. So we have to shield the surface of the metal. So the main requirement जो है to prevent the metal from corrosion is कि हमने जो metal की surface है उसको protect करना है इस तरह से कि उसकी जो surface है वो पानी और ऑक्सीजन इनके साथ जो है वो इंटरेक्ट ना कर सके. सो वी हैव टू शील्ड द सरफेस फ्रॉम दीज टू सो दैट देयर इज़ नो क्रोजन प्रोसेस. एंड वन मेथड इज़ कि हम जो है वो मेटल सरफेस को है वो जो है पेंट कर दें. सो इट इज़ आल्सो इफेक्टिव अगेंस्ट द क्रोजन, बट हैपन्स इज़ के इफ़ देयर इज़ सम रियली हार्श वेदर, ऐसा जो है धूप है, बहुत तेज़ गर्मी है और जिसमें UV लाइट बहुत ज़्यादा है, सो दैट कैन एक्चुअली डैमेज द मोस्टली पेंट सरफेस. एंड आल्सो इफ़ देयर आर एक्सेसिव रेन्स और देयर आर सम काइंड ऑफ स्क्रैच, सो व्हाट हैपन्स इज़ कि जो पेंट है वो जो है वो उखड़ जाता है. एंड आल्सो देयर इज़ if there is extraordinary cold in especially in those area where there is snow, so in winter वो जो है चिप्स जो है बन के उतरना शुरू हो जाती हैं कि जो पेंट की जो सरफेस है वो डैमेज हो जाती है. सो द थिंग इज़ कि पेंट इज़ effective against the corrosion, but in cases if there is some scratch on the surface और अगर environment की वजह से surface of paint is damaged तो दोबारा corrosion जो है वो start हो जाती है. So in that case we have to repaint the surface. Another method is के which is used कि sometimes electric current is used to produce some the passive films or produce the some metal oxide films on the surface. So for that purpose it is provided with current which results in the formation of oxide layers on the surface which prevent the metal to react with the environment. So that is also helpful in prevention of corrosion. And in some cases कुछ metal surface होती हैं, they are treated with the laser actually, so they make them non-crystalline on the surface. And there are some materials if they are in the non-crystalline form, so they are resistant to corrosion. So that can also be a method to prevent corrosion. And in another method is कि हम जो है वो electroplating कर दें किसी metal के साथ के जो inert है. For example, we can electroplate a surface with gold or platinum which are very inert. So ऐसा होता है कि जो भी हमारे पास inert हैं, जो metals हैं जो react नहीं करते हैं, जिनको corrosion नहीं होती, for example gold है या जैसे प्लाटिनम है, सो उनकी जो है इलेक्ट्रोप्लेटिंग की जाती है, कोटिंग कर दी जाती है मेटल की सरफेस पे, सो दैट दे आर रेजिस्टेंट टू corrosion. सिमिलरली देयर आर सम अदर मेटल्स जैसे मैग्नीशियम है, क्रोमियम है, टाइटेनियम है एंड जिंक है. सो दे आल्सो फॉर्म द protective oxide coating. So we can also coat the material with these metal oxides and it will help in the prevention of the corrosion. But in case of iron depend करता है कि जब हम metal oxide जो है अगर उसकी coating करना चाह रहे हैं किसी भी metal की surface पे, उसको avoid करें ताकि वो corrosion ना हो सके. So that actually depends के what kind of metal we are using. There are some metals whose oxides are inert, but there are some metals whose oxides actually can react. So there is no use of coating with those oxides. For example, in case of iron, so iron oxide है, it is actually it becomes porous. So even if there is oxide layer on the surface of the iron metal, but still there will be oxidation because it cannot prevent the underlying surface of the iron to contact with the environment. द स्टील जो है मोस्टली जो यूज़ की जाती है ऑटोमोबाइल्स में, तो उसको जो है वो corrosion से कि वो प्रिवेंट करने के लिए व्हाट हैपन्स कि उसको जो है वो जिंक के अंदर डिप किया जाता है, मोल्टन जिंक यूज़ की जाती है और उसके ऊपर कोटिंग कर दी जाती है जिंक की ऑन द सरफेस ऑफ द स्टील, ताकि जो है उसकी corrosion हो जाए, जिसको प्रोसेस को गैल्वेनाइजिंग भी कहा जाता है. इसके अलावा नॉट ओनली जिंक, देयर आर अदर नॉन मेटालिक कोटिंग एज वेल. फॉर एग्जांपल डिफरेंट काइंड ऑफ प्लास्टिक्स हैं, पेंट्स हैं, ऑयल्स हैं, जिनकी जो है वो कोटिंग की जा सकती है टू प्रिवेंट द corrosion ऑफ द मेटल सरफेस.
If we paint the areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another method to prevent rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps lubricate the moving parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a sacrificial protection method called galvanizing. Have a look at this reactivity table. Zinc is more reactive than iron. When exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put them together, zinc protects iron but is sacrificing itself, hence the term sacrificial protection. This method is applied to prevent rusting on ships. The oxidation of zinc can be described using this following equation. So besides preventing rusting, there is another advantage to this galvanizing process. The formed zinc oxide layer can be removed, and the freshly exposed zinc can corrode once again, thereby further protecting the iron or steel hull.
So as we have learned from the previous animation, that there can be different ways for protecting or inhibiting the corrosion on different materials. So for example, painting with paint can be used to protect the surface from its interaction with the environment, and that can inhibit corrosion. Then like for greasing or lubrication of the moving parts, and then the galvanizing process. So there are different ways. So now normally these days the most common method is protecting the metal surface with some kind of thin layers or thin film coatings. So this is the most commonly used method nowadays to protect the metal surface from corrosion. And the advantages of using thin film coatings are that we can use different materials for the thin film. For example, we can use nano materials for the coating, which actually make very thin layer, and because of the small particle size, they have very high surface area, and their efficiency is very high. Similarly, we can coat with some inorganic materials, we can coat with organic materials, or we can use some hybrid materials. We can even use plastics, PVC materials for the coating. So the most commonly used method is coating the surface of a metal with some protecting material, depending on the application of where we are going to use that material. So the type of coating may differ on the different materials. However, there are some other application. For example, we have aircrafts, we have ships, and there are other application where we have very high temperature. So if we have a application where we're using some material which involves very high temperature, so the most of the coating may get destroyed, and they may not work at those high temperatures, or the pressures, or what we have in the aircraft when they are at high altitude. So for different specific applications, there can be some other ways. For example, for aircrafts, we don't only need corrosion resistance, but we need very high strength of that material. So that specific kind of steels are developed or being fabricated for that purpose, which are corrosion resistant, and as well as they have very high resistance, or from the breakage, or they have very high strength. Similarly, we know that ships, because they have they're constantly interact with the water, and they are more prone to the corrosion, and also they have to bear very high pressure from water. So for that, we have to make some specific kind of material. Similarly, for high temperature resistant, we need to develop materials which actually work at very high temperature. And so depending on the application, So there are different ways for the inhibition of corrosion. So these are the some common ways, and we will discuss these all of these possibilities in our next lecture, that how we can use these different methods for the inhibition or protection from corrosion. थैंक यू, दैट्स ऑल फॉर टुडे. आई रियली होप कि आपको इसमें से कुछ ना कुछ ज़रूर समझ आया होगा. एंड इन केस यू हैव ट्रबल इन अंडरस्टैंडिंग सम टर्मिनोलॉजीज, और अगर किसी चीज़ की समझ नहीं आया आपको, सो यू आर रियली फ्री टू आस्क एनी क्वेश्चन. सो प्लीज़ listen this lecture carefully and let me know if you don't understand anything. Thank you. Allah Hafiz.